and welcome to the LSEC Developer Community. Today we're going to be looking at Python fundamentals tutorial, moving on to Python libraries, where one might think maybe of making their own functions. Here instead we're going to be using functions made by other people, and actually they're called modules, so they are like aggregations and packs of packages of functions made by others and given for free, open source in Python, and are called libraries. You may hear them called packages, just as I've called them just now. Just know that if people are talking about packages in Python, then they're just called libraries. Moving swiftly onwards, I've already opened Codebook here within Workspace. You can do so yourself as well within Workspace, just going on the search bar and writing Codebook, and it will come up and you'll be able to open it on your end. Normally you'll have your file browser on the left. Here I've already got my documents set up, and I've created a new folder and some folders in a folder structure. Here I can have a look at, there we go, the notebook that we're going to be looking at today. And this is a Python notebook for the LSEC data library for Python today. Okay, moving swiftly onwards, I'm just going to get straight into the meat of the subject and show you that you can actually pip install libraries if you wish to outside of Codebook. Now, Codebook is an environment that is closed. You can't pip install libraries within Codebook. If you want libraries of your own in there, you can reach out to us and we can see what we can do. However, you don't actually have to pip install them. Now, for those of you who don't know, pip install is just the way that you can install libraries within Python in your own environment. And what it does is that it reaches out to Python servers, to servers out there that are, again, open source, and collects these packages, collects these libraries for you to use in your own code. Once you've installed your libraries, which again you don't have to do within the Codebook environment, you can import them in your code, and you can do so with a line like this one in cell 1. Import pandas. Now, pandas is one of the most versatile libraries out there, especially for finance and data management. Today, we're only going to go through maybe 3 libraries. I'm going to go through a very narrow selection of them to show you how libraries work in general, and I've just picked the ones that are the most useful, the most commonly used, especially in finance. So here we are importing our library. Note the space here with the import, so we're not putting like brackets like this. It's not actually a function, it's something that's really complex. We're importing the entire library here, and then we can use functions of the library, the pandas library, like this. So we're doing .read CSV. For those of you who don't know, these are basically modules. Modules are packages where you can find functions. Here I'm invoking the function read_CSV within pandas right there, and it's giving me the data that is within this CSV. CSV stands for comma separated value, and what I've done here is I have created a Excel sheet, a comma separated value sheet right there in the same place where my notebook is running. I've got my notebook right there, and I've made sure that within the distro I have my CSV and its data in there, and this is the data. It's quite simple in my comma separated value file. As you can see, it is quite simple. We can move on forward and maybe make some more complex data frames. So here I'm creating my first data frame, and I'm going to call it df1, and I'm going to use the data frame function inside the pandas library. Note the capital D and capital F right here, and we're going to use a dictionary right there with the argument data within our data frame function to create our data frame. So I'm calling it df1. I'm calling my columns here, which are my keys within my dictionary, and the data we're going to delineate inside lists. I have my 2 lists here with my 2 columns, and it's giving me a data frame right there with indices on the left, starting from 0 going onwards. Now remember, in Python, most things, if not all things, are 0 indexed. So here the first row is 0, the second row is 1, and in pandas lingo, the rows are actually called indices. So it's index 1 and index 2, or index 0 in this case, and index 1, moving on forward like this. Now I'm not going to want to write pandas, the entire name of the library every time, so I'm going to shorten it. I'm going to shorten it to PD, and I can do this right there. So import pandas as PD, and I'm going to use again the same function as I did before, the data frame function, but however with my abbreviated library name right there to create my new data frame. So this is going to be data frame 2, and I'm going to be moving onwards and rename that index, because I don't like 0 and 1. I'd like the index instead to be index A and index B. Now note that the very first time we did this, we had numbers here. These are integers. If I was to have a look at the index, just as I'm doing right there, I get a range. Now, this is extremely similar, if not exactly the same, as the range function within Python. So if I was to do range 10, it's going to show me, there you go, something like this. So I'm going to be range from 0 to 10. Again, it's exclusive with respect to its upper limits. So it's going to be ranging from 0 to 9, exclusive with respect to 10. And here, however, it says that we're starting at 0, stopping at 2, and steps are 1. You can do the exact same thing with range. So here we can do start at, let's say, 0, end at 10. Let's do steps of 2, and that's exactly what's going to happen right there. So if you want to create your own indices in integer form or things like this, you can use range functions right there. Now you may ask, how can I create my own indices? How can I overwrite the indices that already exist within a data frame? You can do so with the index function or the index module right there and assign a list to it. So that's what we're doing right there. Instead of having numbers, unlike strings, I want it to be a string that says index A and index B. And we can go on forward with our data frame df2 with these two indices. I can also change the columns in exactly the same way. df2.column, and then I've got my list full of strings with my column A and column B. You can manipulate data frames, and that is really where Pandas starts to shine. Before, it was just kind of a data structure, just a way to store your data, similar to a list or a dictionary, but we can go much further on with Pandas and manipulate our data frame. So here what we're doing is that we are appending. So we are adding, if you remember, what was df1? df1 was right there, and df1, yes, I did not actually run this. I was running it up to now. So what we can do is run each cell ourselves. So we can do that right there. I've got my cells running, and we can go all the way to our appending. So if we have a look, what was df1? df1 was, there you go, this was our df1, and what was df2? Let's have a look at whether or not it appended them correctly. Yes, it seems like it has appended them correctly. So look at df1, which was with 0 and 1, and 1, 2, 3, 4, and we went on all the way to 8 here, and we've appended them. However, have a look at how this has put things together. We have basically two data frames in diagonal. Maybe that's not what you expected exactly, but what's happening here is that Pandas is noticing that both the indices and the columns are different. Therefore, it's added the columns and it's added the indices, and now we have a basically new data frame with the two data frames next to each other. Maybe that's not exactly what you want, so let's create a new data frame, call it df4, and let's add df1 to df4. So here df4, you see, has the same indices, so 0 and 1, and has the same columns, I believe, yes, column 1 and column 2. So if we were to create df5, I just ran that cell, and we can see that df5 is appended maybe in the way that you would expect. By the way, this kind of appending with a data frame kind of in a diagonal format is perfectly fine if that's what you're asking for. But you will have these empty cells with NaN, which stands for not a number. And if that's what you're looking for, go for it. Now, what you can do is you can try and seek information within a data frame. So here we have our df5, but note that it kept the same indices, because the index in df4 is 0 and 1. The index is in df1 is the same. Therefore, if I was to seek information in a row for which the index is 0, notice that there's two of them. There's this one right here, and then there's this one right there. So if I was to do .log, which by the way is a function that allows you to seek information inside a data frame with regards to its row, and then put 0, is going to return two rows, because 2 rows are named 0. That's why we always advise having unique indices in order to be able to seek unique information inside the data frame. But again, this is perfectly correct if that's your seeked outcome. So now we have our data frame. Let's create a new one. Let's say df6 with columns 3 and 4. And let's create our new data frame df5, merging df2 and df6. Now, I actually forgot what df2 was, even though we just had a look. So let's have a look right there. Okay, this is what df2 looks like, and this is what df6 looks like. Let's have a look at what happens if we were to merge them this way. Well, I mean, you can already look by the way it was rendered when I was rendering this notebook earlier today. That's what it looks like. What's interesting here is that we have our merge. So now we have our data frame on the left and on the right, but it's added this row called key_0. The reason for this is that the common denominator between the two data frames was chosen to be df2.index. So here we took the index of df2 and we said merge df2 with df6 on that index. And so this is what is created right there. However, we now have not only just the index for the F2, but also the F6. Therefore, what's happened here is that the index for the F2 was added as a column. Now you can remove it, and you can do whatever you want with that column. But I wanted to point that out to make sure that we're not losing any data when we're doing merges. Okay, let's try and do the same thing then if we just merge df1 and df6. Now notice that we have this error, and that's because in truth we really shouldn't be merging. Merging is not the best function to be using within pandas. We should use joint, which is right there. However, you can, if you want, really push for merge. In which case you have to specify indices. So here we selected that we were merging two data frames on tf2.index. That's perfectly fine. But you can choose to do so with the left and right indices. So here before we had only a left index. So here df2 is on the left, df2 in that function is on the left. That was the left index, and df6 is on the right. And you can choose your specific index to index on, to key on in order to merge. So here df1 is on the left, df6 is on the right. Our left index is going to be set to be true, so we're going to use the index of df1 as a key, and we're also going to use the index of df6 as a key. And this is what comes out right there if we were to do this. Now let's have a look at the data frame so that we don't forget exactly what we're doing. We have our indices here, 0 and 1. Let's have a look at df6. What was df6? We have our indices again, 0 and 1. So notice that we do not have this column here, key 0, because we have the same index for both right there, right here. Okay, moving onwards. As I said, we should probably be using joints. These are the preferred ones, and by default is going to choose these left and right indices for you. And that's exactly what's happened here. So if I was to use join here to create this new data frame called df9, it's done exactly the same as what you see above, automatically choosing the left and right joints. Now you can do some crazy things with this called maybe inner joints, outer joints, left, right joints. You can have a look on Google or anything as such about this in order to manipulate your data frames. But I just wanted to really quickly show you what you could do to manipulate data frames within pandas. Now there isn't only just that. You can also do some calculations. Normally they're quite rudimentary, but they can get quite complicated quite quickly. So here, for example, I'm just giving a very quick example of sums. So here I'm saying, okay, within df9, I would like row 0, and I would like the sum. I would like the sum of all the numbers within row 0. That's what's happened right there. I can do the same for columns. So within column 4, which is this one, I would like to have the mean, not the sum, but the mean. And you can go on like this. You can even have like geometric means and things like this, which become very useful in finance. Moving on, I purposely created these data frames right there with different information left, right, and the center in order to show you what merge and joints can do. I spoke about it in a joint, and this is what happens right there. So I've got my df10, 11 that I've created right here, and df12, where I am merging df10 and 11 inner. Inner means that I am only keeping data that exists in both data frames. If I was to do outer, it would give me data that only exists outside of these two data frames. What I mean by that is data that only exists uniquely in both data frames. If it exists in both, it will be removed. That's with the outer. Here we're doing inner, so it's only giving me information that exists in both. So here, if you notice, my key, which is just a random column that I've created, by the way, right there, I've called it key, has k0, 1, and 2, and df11 has key 0, 1, and 3. So notice that df10 does not have k3, and df11 does not have k2. So what I'm expecting is these two rows to be removed because they do not exist in both data frames, and that's what we're seeing right there. df12 has removed these two rows because they do not exist in both data frames, and it's giving me a wholesome data frame right there. You can have more information. You can look it up with this link that I've added here. You can have access to, or just as I said, it will be in most places, maybe Google or 3 places as such, if you want to read more about it. I've very quickly showed you what a transpose is, reason being that I use it quite a lot. You may see it in data analysis videos out there, but all it does is that it makes the columns the indices and the index the column. It's that simple. It switches them around. Something that's extremely useful in data analysis, especially in econometrics, if you're doing, for example, autoregressive modeling, would be a shift. So maybe you'd like to have the same data but shift it up once or shift it down once, and it's that simple, really. I have created here a new column, which, by the way, this is how you can create a new column in Pandas, with square brackets next to your data frame and the name of the column there, and you can delegate data to this new information. And we have it here, and I'm saying that within df13, I would like to shift whatever was in 0. So here, if you remember, we transposed the indices and the columns. So 0 is a column, and what I'm doing is I'm saying I would like to shift the data -1, so it goes up 1. And this is what's happened right there. So let's say I want to find out, let's say 23 is my y, 24 is my x, and 23 here is my x -1. I can regress one on the other and its lag right there. You see, I have my lag right here, my independent variables on the right. Now, this is just a way to do it right there, if that's what you choose to do. I've done it in the past, and this is a very quick way to do it. That works quite well. You also have filters. So you could have your data frame whereby you only want column, let's say A and B. So let's have a look, because again, I have a very bad memory. Let's have a look at what df12 is. This is what df12 looks like. Let's say I only want column A and B. What I can do so with this right there. What I remember thinking when I saw this is, why is there 2 lists? Why is it a list within a list? Well, the reason is because maybe you have a very, very complex logic in your code. And at the end, your logic is giving you this list right there. Whatever the logic is, you're not interested in, maybe you're not interested in bid, you're not interested in ask. Maybe if you have both bid and ask, you want to calculate a mid yourself. There are many reasons why you may have some complicated logic to create your list. And I've got a list right there. And what I could do is I can put my list in here. It's literally, that's why it's two square brackets, so that you can have a list inside your square brackets. And if you were to run this, there you go. You have only columns A and B from your data frame, the df12. I've spoken about how you can look up some rows. So here, the iloc function can look at row 0. You can also have the loc looks at columns, which would work perfectly fine. And if you move on forward, I've given you a very, very quick, complex example of quite how you can mix and match the different techniques and advances that may be at the tip of your fingers going forward. So here I'm using a lambda function. It's quite complex, but what it does is that it, as it says here, it collects data within the data frame that contains A or 0. And here I'm creating my function, and it works per row. It looks at each row and looks for A or, and we have that or right there, the same thing that has 0, collecting us this data, bringing it forward for us. This was a bit complex. I'm not going to speak more through it. If you're interested, have a look at this. You can copy and paste it yourself and use it for your own data analysis going forward. As I said, I'm not going to be going through too many libraries. We went through Pandas, which is the most famous Pandas data frame library. But I wanted to very quickly go through NumPy and SciPy. They are 2 mathematical and statistical libraries that you can use. So here what I've done is I've imported the NumPy library and shortened it to NP, which is done quite commonly. But here what I'm doing, instead of just importing the library, SciPy, and then using it as I did, for example, Pandas, or as I will with NumPy, I have specified that I want a specific module inside a module that itself is inside the library. So here I'm saying I want to import that library, SciPy, but actually I don't want the entire library. I just want that module, stats. Actually, no, I don't want that module, stats, within the library, SciPy. I want just the module norm inside the module stats. And I'm really specifying quite exactly what I want right here. Now, norm is only just there to create values from the normal distribution. And what I'm doing here is I'm defining a very simple function to create Black-Scholes model formula results. I'm creating some prices implied by the Black-Scholes model for option prices, for options. And again, we have our doc strings here. Don't forget to have your doc strings so that everyone understands what your function does. I have my parameters, your initial stock price, strike, your time to maturity, risk rate, volatility. And I can use all of these arguments here inside my function to then define D1 and D2. Now, D1 and D2, don't worry if this is a bit too complex in terms of the mathematics that's showing right there. But what I wanted to show you was this right here. I am using the NumPy library to collect or to use the log function in order to make the log, the natural log of these two values. Now, I don't actually know by heart if this is the natural log or log base 10, but I'm just using it here for example reasons, just to showcase how you can use this function within this library. Going forward, if you were to read this, so this is just a formula. You don't have to understand exactly what's going on in this formula, but I'm using a few of these functions that I'm collecting thanks to these libraries that I've collected. That would take me quite a while to create on my own, was I to define the function every single time if I was to use it and create it myself. Here I've got another one, so square root. The square root is an awful lot easier to use in Python because you've got the stars. If you remember, star means to the power of, so you use star 0.5, that would be square root. Nonetheless, we have a square root function right there, so let's use it. And I'm also using the norm module that I have imported right there. So I'm importing the norm module, and I'm using the function CDF inside the norm module that I've imported above with my my arguments right there. So notice that these are exactly just like functions we can create ourselves. Here I've created a function. I have the parameters that users of my function can use as arguments. And here all I've done is I've used the function that someone else has created. Someone else created a function in exactly this way with specific parameters, and I can use them as arguments right here. And I can put it all together. And here, by the way, I've got another one, np.exp. So that's to the power e to the power of something. It's exponential, and I can create whatever I want with these libraries. So here, what I've done is I've put all this together in order to give me a Black-Scholes model implied call price and put price, and I've returned them right there. Now, I haven't spoken in the past about tuples. This is what's being returned here. It's a tuple, so it's not a list, it's not a dictionary, it's a tuple. We don't really have to dig too deep into what these are, but basically the order inside a tuple doesn't matter, so you don't keep the order, and also I believe you can't change them. The whole idea is that you create them for them not to be changed in the future. I think you can append on them, but you can't change what's already there, or at least you shouldn't. So I've created my function right there, up here, and now what I can do is I can create my two objects that will be returned from my function right here by calling upon my function here, Black-Scholes, with the arguments that I'm going to choose. So here I've chosen stock price 100, strike 105, all the way to my sigma that I've given here as exogenous variables I've inputted myself by hand. I can then print my call price, and notice that I've purposefully used two different ways to print. So here, this is using just comma separated values within the print function, which works perfectly fine. You can see here that it's giving me a call price right here, or the f string technique, whereby I've created my f string right here, put price with my value put price here that I've created up there, and it's printed it out right here for me. Last but definitely not least is matplotlib, which is one of the simplest graphical libraries out there, which you can use to graph. Let's say we were to use our function here, our Black-Scholes model, but not just with one stock price and one strike and one time to maturity, but let's use 10 of them. Let's say we go 100 and 100. Let's say 110, 120, 130. We're going up in tens, using this range function right there, and we're using this list comprehension to create our stock price. So let me just show you very quickly what this would render. Here, there you go. We've got our list comprehension, so 100, 110, all the way to 190. We're doing something very similar for all the other arguments, all of these other objects that we're creating. And we're going to, if I was to double click on it again, you're going to see, there you go, bottom right here, we have that that object that is highlighted inside the cell. And I can see that what's going on is I've created this object right here, and I'm using it right there. I'm doing this all the way down. I'm also using the date range function inside the pandas library. So what I'm doing here is I'm just simply creating a list of dates starting on, there you go, the 1st of January 2024 in periods of 10, let's say weeks, 10 weeks. And I'm converting them to a list. So I don't want it to be a tuple. I don't want it to be a pandas object. I just want it to be a very simple list. And that's what's going on right there with my list date. Moving forward, I can create a dictionary where I have my two keys, my call price and my put price. I've chosen to call them with strings. And I have my two empty lists that I'm going to append in a for loop. And here is my for loop. So I'm saying for each of these objects, so I've got my stock price, my strike, my time to maturity, I've put an underscore in front of them in order to make sure that I don't mix between the arguments that I have within my for loop and the arguments I'm using inside my formula. I think you can actually, I'm pretty sure you can just ignore those. You can not have them there. I've just put them there to make sure that I know which one is the argument inside the for loop and which one is the argument to be used inside the Black-Scholes function that I've defined. And what I've done here is I have to iterate for each one of these inside my function. And I don't know if you've gone through this before, but if you have, you'll notice that you can't do this. You would have to use a zip. What we're doing here is that we're iterating for each stock piece with a strike price, with a time to maturity. We have to have as many objects inside each list, or else it's going to concatenate and just leave it to the shortest list. So we're using this zip right there to iterate through each one of the lists to use inside of our function right here in the for loop. And we are appending the list that exists within our dictionary here called call put dictionary with that value that came out. So here I've got my call price that is created with this function. I'm appending it inside that list right there. And the reason I've done this is that we have something like that. And then all we have to do is that we have to create a pandas data frame for it. So here all we've got is a pandas data frame. I don't think I've run every cell, so let's just run these. I believe that will work. There you go, it's working right here. Now this one takes a short while. There you go, to create our graph. But what I wanted to show you is what the data frame would look like. That's what it would look like. We have our data frame with our dates here, put to the left. Here we have, there you go, we have our index, which is our list date, which we have created right there. As you can see, it's being highlighted because I've double-clicked it at the bottom. So this is our date range. We've put it as an index, so we've got it here on the left. And I have decided to plot it very, very simply with a dot plot at the end. Now, this dot plot function uses the matplotlib library. However, I believe you don't actually have to import it yourself. Yes, you can see that I didn't do this myself, but you can import the matplotlib library. Have a look online at how you can use this library and its functions in order to plot data. And we've got our plotted data right there. It really is this simple. On the x-axis, we've got our date, and on the y, we've got our prices right here for call it input prices. You can find out more about matplotlib here in this hyperlink that I've added for you. Okay, this is quick and short. This was just a library, a video to go through simple, quick libraries, the ones that are most often used in data analysis and finance, for us to get used to how you can import and use libraries and modules so that it doesn't seem a bit too drastic going forward. One of the reasons I wanted to show you all this, even though it may seem a bit simple or maybe doesn't seem to be going anywhere, is because now that you understand how you can import and how you can use these modules, if you were to read a piece of code that is very complicated, let's look, for example, let's go back to that Black-Scholes model. If I was to look at this and think to myself, I really don't understand what's going on here. If you're trying to understand these things, what you can do now that you understand how these things are imported, I can copy this. See, I'm highlighting it, Control-C, Control-F. You can go there and Control-V. And now you can see norm dot is being highlighted. So if I was to go norm, let's go up. And what I'm doing here is I'm looking for that place where it's been imported inside the code. And I can see, there you go, it's been imported right there. What that means is that it's from the SciPy library. And now I can look up the SciPy library online to try and understand exactly how that norm module or that norm function works. Okay, I hope this was useful. And going forward, we can do some much more complex things, defining our functions using libraries. And I hope this was of great use. All right, thanks for watching.